what I wanted to talk about were fragmented views, the solid angle and the search for quantifiable view metrics. It's really continuing much of the work that we've been hearing about all morning long. And I wanted to show you some of the work that we've been doing in our practice that applies view standards to projects. In our practice, we deal commonly with a lot of complex buildings, and we found that existing metrics don't account for things like multiple view apertures or discontinuous views like you're seeing in this image here. And additionally, the existing metrics typically use linear angles to measure view size, and this presents some interesting conundrums in practice, which we'll discuss in more detail. We've been experimenting with some alternatives using solid angles instead of linear angles, and we found that this method is a good predictor of view quality access, but there's still some research gaps, and I'd like to go over these. So our firm specializes in low energy lighting, daylighting, and high performance buildings. And we often use our office as a test bed for researching and inventing new design methods and technologies. This is our office on the left, and when we working in there, we have these two really distinct views of a marina. One out to the water and the hills beyond, which is an astounding view by any measure, and then one to a parking lot and some industrial warehouses that some might not consider great views, but we really valued in our office. But this sort of our glut of wonderful views comes into more focus working with others. And I had the opportunity to go into an office in a half basement in San Francisco where they have this view over here. When I asked someone how they liked their view, they said, "It's great." And I said, "Really?" Let me zoom in so you can see. There's the plant that Christoph was talking about. But you know, it's a view out to a kind of a tough courtyard. But the other alternative is this view over here on the right, which is maybe not the nicest view. And so they were really wondering, or got us wondering about what are the limits to views? What are the thresholds of acceptability for views? And this got us like coming back to basic principles. And we've been over this a few times today, so I don't want to go into this in great detail. But as others have pointed out, the point of having a view within a work environment or classroom environment is to understand our position relative to the collective in terms of our psychology and sociology, resetting our mind as a source of distraction, relaxation, and delight, allowing our eyes to relax, adjusting our focal length, allowing for luminous contrast and change in our pupils and our musculature, and our circadian response, both hormonal as well as our cognitive response to variations in light intensity and color. And all of these things provide important benefits. And the question that we have is really, at what point do you not get these benefits anymore? And so we developed a kind of series of view quality indices, very similar to what Wan He presented earlier. In fact, we co-authored that with the view index with her and advised on it. And we've been using in our practice these four components to view quality, which are access, the perceived size of the view within a view corridor, content, which provides sufficient interest and variation, openness or clarity, which is the degree of transparency through the view aperture. And then we've actually separated out what we call view maintenance, the amount of time that the quality view is accessible, as opposed to conflating it into clarity. But in this talk, I actually really want to just focus on access because, as I pointed out before, there are certain limitations to the existing metrics for access. When we when we look at view access or sort of view quality within a building, we are looking at all of these 4 components: access, content, maintenance, and openness. And we will typically look at this in early design phases all the way to the end of construction and commissioning in order to understand the relationships between positions in the floor plate and views. For buildings like this, which have very, very large floor plates, we have clients that are not necessarily asking about how to achieve the best views, but really how to achieve the most area of acceptable views. Because their goal, the client's view, is to balance large and deep floor plates with occupant satisfaction. How do they kind of get the most occupant satisfaction in the largest space? And that's really what I wanted to dive in a little bit deeper on in terms of the ability to access a quality view. So this comes back to, well, I wanted to start with the study that the Heschong Mahone group did in 2003, and I wanted to recognize that Lisa is here as a participant, so thank you for joining us. And in their research, in this study, they looked at the impact of views and daylight on office worker performance, and set up a sort of set of categories of view acceptability, from a very good view with over 50 degrees angle to it to a very poor view with less than 5 degrees. And they decided that the smallest acceptable quality view would be about 11 degrees, which you see as a sketch here. This is part of their paper. And what they came up with was that the smaller of the vertical angle and the lateral angle, it would be the threshold for determining the size of the view. So in this 11 degree, whichever the vertical angle or lateral angle was smaller, if that was greater than 11 degrees or greater, then it would be an acceptable view. So we wanted to test this in our own space. Oh, whoops, before I get to that, I wanted to point out that the linear angles present some problems with very complex spaces. And this is a space that we've recently been analyzing in our office. And this is a 180-degree view in that space that has multiple clerestory windows of different shapes, multiple perimeter windows of very different shapes. And so we wondered, using existing rubrics, how do we characterize these? What is the horizontal and vertical linear angles to these? How do we count interrupted views? How do we, can we aggregate multiple windows? Do clerestories even count? Is there a vertical cutoff angle we should consider? And is there positional flexibility? Is there a horizontal cutoff angle? Can we look over 180 degrees or 360 degrees, or should it be more like 60 degrees, as one of the presenters suggested earlier today? And in order to do this, what we wanted to know is, would it be possible to extend, instead of linear angles, can we extend linear angles to be solid angles? And solid angles are basically the 3-dimensional cone of vision that are composed of the linear angles. So here you see a vertical 11-degree and a horizontal 11-degree angle. If you had a square aperture, would be 121 square degrees solid angle. And we can visualize this easily by taking a rectilinear projection, as you see up here, and changing it into a hemispherical projection, where it is equal angular, meaning that the area of the surfaces are equal and have the same solid angle. And so we can just sort of count up the squares in order to arrive at the number of square degrees for a given aperture. We wanted to calibrate how we thought about this by using our space. So this is the view through that window in our office. And we did a a very unscientific scientific study of our office, 10 people, and we said, when you're standing here 16 feet from the window, do you feel like this is a quality view, enough to distract you when you're sitting there and to give you a reprieve from your work? And everybody categorically said, yes, this is a great view. And with this view, the horizontal dimension at the smaller window is precisely 11 degrees. The vertical is 28 degrees. And if you take the whole thing, it's 22 degrees by 18 degrees. So this right-hand window has 200 square degrees, and this whole, both windows together is about 400 square degrees. So then we backed up in the space, and if you're 37.5 feet from the window, was this okay? And most of the people said that this right-hand window at this point was pretty close to where they would consider it acceptable. Like, if you back up a little bit more, it wasn't going to be so great. And at this point, we were, the linear angle was 5 degrees, and the vertical was 8 degrees on this right-hand panel. So that would be 38 square degrees. So that was just about the threshold where we thought it was acceptable. When we backed up even further at 59 feet from the window, no one thought that this was acceptable. And this was down at 15 square degrees and 31 square degrees. And so this is just one data point that we were using as a hypothesis. So then we took this, and by the way, that was a pretty simple example, right? Not very complicated, just one small window. We took this to a much more complex space and wondered how this would work. And we enlisted 4 people to come rate these different views. And you can see these fisheye views on the bottom. All these views look very small because in the fisheye, the view is distorted, and things that are in the middle in particular look very, very small. But interestingly enough, to make a long story short, the threshold of acceptability turned out to be right between 40 square degrees and 80 square degrees in this study, which coincidentally kind of dovetailed with our office study. And then we took this to that building I showed you previously, a large floor plate building, and tried to map what would the linear angles and square degree solid angles, how would they map onto this as you move through the space. So this is a huge view, 5,500 square degrees. As you move back, 1,400 square degrees. As you move back even more, 450 square degrees. And it was at this point that we reached the threshold of that vertical 11-degree linear angle, meaning that if you take one step back from here, LEED would no longer consider this a view. But by our solid angle method, we thought that this actually still had a pretty decent view. Not great, but probably acceptable and enough to provide a distraction to someone working in the space. We wondered how in aggregate this would map to the 11 degrees. And so what you see here in blue is all of the places where it is less than 11 degree linear angle, and the gradient shows the solid angle. And so in the middle of the building, that 11 degrees maps pretty well to about 121 degrees or so. But we find that there's lots of areas around the periphery, particularly at the oblique angles, where the LEED criteria don't hold up quite as well. And in fact, solid angle might be a better way of predicting. Another way of saying this is that with that complex facade, we found that none of the apertures would comply with LEED 11-degree criteria. But if you aggregate them together, there are over 1,400 square degrees of view. And so finally, I just wanted to give you a kind of like our plea for some more research in this, perhaps some more rigorous research than we're able to do, we would highly advocate for establishing acceptability thresholds using large-scale, in-person and peer-reviewed human subject surveys. And we'd really caution against virtual or image-based studies, because we've really found that the things that are in person have a huge impact, with particularly an emphasis on minimum size and maximum distance requirements. And we can get to some of the more intricacies of this perhaps in the questions, but I think this is a good place to leave this. I just wanted to thank my collaborators at Loisos Ubbelohde, particularly Susan, Michael, Alan, and Stefan.